Hello everyone and welcome back. My name is Mr. Kovalt, and in this video, it's a continuation of the practice problems. I'm going to go over one more practice problem number 3, which involves rather than a solid and a liquid, 2 liquids. So here we're going to mix 2 different volumes of water at different temperatures, and we're going to solve for the final temperature. So here we have a 100-gram sample of water at 50 degrees Celsius. That's going to be mixed with a 50-gram sample of water at 20 degrees Celsius. You mix them together, you get a total of 150 grams of water. What is the final temperature of that 150 grams after you've mixed them and mixed? Okay, so basically same type of problem. So we're going to do Q1 is equal to the negative of Q2. So this would be our first sample of water. This will be our second sample of water. So let's list our information. So sample number 1. So we're given the mass of sample 1 is equal to 100 grams, 100.0 grams. The initial temperature. So we know the specific heat of the water is 4.18 joules per gram degrees Celsius. Our initial temperature, T initial of the first sample, is equal to, where's the initial temperature? 50 degrees. So 50.0 degrees Celsius. And we're trying to find the final temperature of sample number 1. Okay, so we don't know that. So sample number 2. So for sample number 2, we have 50-gram sample. So the mass of sample 2 is equal to 50.0 grams. Again, the specific heat, since it's water, the specific heat of this is the same as the other one, so 4.18 joules per gram degrees Celsius. So same specific heat. And our initial temperature is 20.0 degrees, so the initial temperature of sample 2 is equal to 20.0 degrees Celsius. And our final temperature, I'll write here. So temperature final is, again, we don't know. Okay, but we do know is that the final temperature sample 1 and the final temperature sample 2 are the same. So these two are equal. So the final temperature of sample 2, so temperature final for sample 1 is going to be equal to temperature final of number 2. So these are equal. So that's going to help us calculate or solve the problem. So now we just put in our equations. So we're going to substitute this in for Q1. So here it's going to be the mass of sample 1 multiplied by the specific heat of sample 1 multiplied by the initial temperature of sample 1 minus the final temperature. So we're just going to call this T final because they're the same on both sides. So instead of T final 1, it's just the final temperature for both of them. And that's going to be equal to the negative, and it's going to be, again, the mass of sample 2 multiplied by the specific heat of 2, which is going to be the same because they're both water, multiplied by the T initial final temperature, I should say. Final temperature. Oops, I mixed these up. So it should be T final minus T initial for the first sample, and then final minus T initial for the second sample. And so there's our equation. So then all you do is just plug everything in again. So let's go ahead and plug everything in. So we have 100. So the mass of one is 100.0 grams times the specific heat, which is 4.18 joules per gram degrees Celsius. And then we have our final or temperature, which is what we're trying to find. Oops, I forgot to multiply. So multiplied by TF, which is what we don't know, minus the initial temperature, which is 50.0 degrees Celsius. So 50.0 degrees Celsius. So that's our one side of the equation. Let me kind of move this over to give us some space. So that's going to be equal to the negative of this. So the mass of our second sample is 50.0 grams. So 50.0 grams multiplied by the specific heat of water again, which is 4.18 joules per gram degrees Celsius. And then we have our final again, which we don't know, our final temperature. So again, that's going to be TF, T final minus the initial temperature, which is 20.0 degrees. So 20.0 degrees Celsius. Oops, let me scoot that over a little bit. So now we have our equation. So this is equal to the negative of this. And so all you're going to need to do is multiply these together, distribute this to both of these, right, to the TF and this. So you're going to have to multiply, distribute between the TF and 50 degrees, negative 50 degrees, or minus 50 degrees, and equals, and then distribute the negative here. So again, multiply these, distribute the negative number to TF and the minus 20. And then when you do all of that, you can solve for TF. Now, one of the things that's going to simplify this is notice that 4.18 here, the specific heat, and here the specific heat is the same. So you can actually cancel those out. But if you forget to cancel those out, the math works the same. So don't worry about it. But if you remember to cancel these out, then it gets a little bit easier. But again, you still have to distribute this number here from this. So if we cancel those out, so you can cancel these out, and then you don't have to worry about multiplying with these two numbers. But you do have to distribute the 100 grams here. So you have to multiply out the 100 times TF and the 100 times minus 50. And then here, 50, the minus 50 has to be distributed to the final temperature and the minus 20. And then you just do the math, the algebra, and what you should get. Oh, sorry about that. And what you should get for an answer so TF is equal to 40 degrees Celsius. So that's what you should get for your answer. Sorry about the bell. So I hope you enjoyed this video. If you like this video, please like the video, hit that like button, share the video with your friends, subscribe to my channel, hit that notification bell. Make sure you also hit the all button so you can be notified by all the videos I put out. And also put a comment down below in the comment section. Let me know what you think. I'd like to hear from you. If you have questions, please ask. Thanks for joining me. Have a great day.